Hello everyone, I'm Bernard Jin from FTC Team 17080 NewT.exe, and today we'll be talking about linear motion. So starting off, what is linear motion? Linear motion name is fairly self-explanatory. It's moving things in a straight line, and it's used in FTC, it's used most often for extensions outside of the 18-inch size limit. For design considerations, you'll want to consider the weight of your linear motion mechanism, particularly if you're going to stick it out a fairly long distance. It's going to create a lot of torque, and it's going to move your center of gravity. So generally, you want your linear motion systems to be as light as possible. Next is speed. How fast do you want your linear motion to extend? Your linear motion mechanism to extend? Generally, the heavier it is, the slower you'll have to extend, or the more power you have to allocate to it. Next is friction. Different linear motion solutions have more or less friction, which depending on what you're using it for. If you're using it to keep something in place, friction might be a good thing. But if you're using it to extend outwards and retract rapidly, then you want to minimize friction. Strength, again, if you have something heavy on the end of it, that produces a lot of torque, and a lot of that torque is going to be on the linear extension itself. So if you have a heavy mechanism on the end, you'll want a strong linear motion mechanism. And finally, length. Depending on how long you want to extend outwards, you'll have to design your linear motion mechanism to match that. So starting off, we have drawer slides. Drawer slides are slides that you find in almost every single organizer. They are slides, and they have a base, which is the part that doesn't move, and a carriage, which is the generally smaller part that does move, although some slides, like the Masumi 3-stage ones, have a runner section in the middle. The advantages for these are that because they use bearings, they're generally very smooth. And because they have an all-metal construction, they're also strong. And you also have a huge selection of drawer slides that you can choose from. For example, Masumi has their SAR series, Long Robotics has their own slides, and Go Builder released Viper slides. Unfortunately, because these are generally not meant for FTC applications, we're going to have to extend it a huge distance with something heavy at the end. Sometimes they're not very durable, and they come with play, which also, with the Masumi slides in particular, since the balls are made of steel and the rest of the slides are made of aluminum, the balls will wear away at the rest of the slides, and it will introduce play as you use it. Availability, popular sizes for slides, for example, SAR 230s, run out very quickly, particularly at the beginning of the season. And finally, because none of these slides adhere to a specific, or very few of these slides, I should say, adhere to a specific build pattern, you oftentimes have to do custom mounting with these. Although, for example, Go Builder slides interface well with Go Builder parts, and I think Long Robotics are for Activotics, Matchwell Activotics. Next up, we have extrusion slides, which uses bits of extrusion, which is basically a single pattern stretched out into the third dimension, and sliding inserts. The advantages are that because you're using extrusion, and you can cut the extrusion to any length you want, they are extremely highly customizable in length. And also because you can screw in anywhere you want along the extrusion, they're also very easy to mount on, easy to mount. Unfortunately, they are high friction, especially the rev slides in particular, because they use sliding components. Although this is mitigated by the fact they use Delrin, which is a fairly low friction plastic. They're also large because you're constrained to the size of extrusion as sort of like a minimum size. And extrusion the most extrusion is square, so you'll be stuck with a slide that's at least that's much longer than you normally get with other solutions. And finally, because oftentimes use plastic inserts, as well, because they oftentimes use plastic parts, they also flex easily, which means that they might not be the best choice for long or heavy duty extrusion extensions. Next, we have linear rails. Linear rails uses steel rails and carriage blocks. The rail is the long portion that has the hole pattern, and the carriage blocks are the smaller components that move along them. The advantages are that they have a small carriage, meaning that you won't have to, for example, with the drawer slides, you have a runner you have a base that's as long as the carriage, which means that you'll oftentimes end up with a lot of the slides sticking out the end. With these, because they have a small carriage, they don't stick out as much. They're also customizable. If you want to get really crazy with these, since the rail is also an extrusion pattern, you could cut that to whatever length you want, although they're oftentimes made of steel, so they might be a bit difficult to cut. They're very smooth. The carriages actually have a track of recycling bearings inside of them, which minimize friction. And finally, because they're made of steel, they're very stiff and very strong. Unfortunately, they're heavy. Again, they're made of steel, and there isn't huge community support for them, at least in FTC, which means that you'll probably have to design your own mounting. These types of slides are generally used for fairly short extensions, sort of like the last mile, or the last inch extensions, I should say. Next up, we have double reverse 4-bars, which uses a pair of 4-bar linkages that, as the name implies, are reversed. So the end of one is connected to the bottom of one is connected to the top of another, as well as flipped over. And this creates linear motion. And the advantages are that they're light, because you don't have to deal with ball bearings or that many sliding components. So because you don't have to deal with a ton of ball bearings or sliding components, they're generally fairly light. They're also their lightness also allows them to be very fast. And finally, because they use arms instead of slides, they can be thin. Although the trade-off with that is that they're very long. As you can see on the robot on the left, the lift mechanism extends across the entire robot. They're also high torque because you don't have a spool. You don't have a small spool to lift up with. Your spool is sort of like the length of this arm, which will impart a lot of torque on your robot. And finally, because their construction is fairly thin, they also are a bit lacking in stability. Although generally this isn't much of an issue, but if you're carrying something heavy on the end, for example, another set of slides to extend horizontally, then double reverse 4-bars might not be the best choice. And finally, we have something a bit esoteric: tape measures. Tape measures, magic mechanisms use a tape measure that you can just buy at Home Depot or some other hardware store, as well as some sort of extension mechanism, usually a wheel, to stretch huge distances. The advantages for these are that they're light. You don't have to deal with a bunch of metal slides. You just have a single tape measure as well as a wheel. And they're also small. And comparatively, they allow for huge extensions that reach across the field. Unfortunately, because tape measures use a single sheet of metal, they're often lacking stability and strength. There are also a lot of times lacking in speed, especially if you have a servo connected to the tape measure. And finally, because there isn't sort of like locking mechanism between the tape and whatever you're driving with. You're relying on friction only. They can slip, and that means that they might be lacking accuracy. Generally, these type of mechanisms are only used for auxiliary purposes. For example, if you're trying to park, you can stretch it across the field, or if you're trying to score a small very light element while you're doing something else, for example, the beacon during Freight Frenzy, you might be able to use a tape measure mechanism. And then we have to talk about rigging. Rigging is how strings is how strings or some other mechanism is going to be connected to your slides in order to let it extend. Here we're only going to talk about strings. And for stringing, we have continuous stringing, which is this example on the left, and cascade stringing, which is this example on the right. So starting off, continuous rigging uses a single continuous string for extension and a single continuous string for retraction. And with this one slide goes up at a time as you turn the winch. And the examples for the advantages for these are that they're simple. You only have one string going up and one string going down. They're easy to tension, and the extension length is 1-to-1 with the amount that you spool. So you don't have to compensate for that if the end moves a different amount that you spool in. Unfortunately, because extension length is 1-to-1 with the spooled amount, these slides are this rigging is a bit slower than cascade rigging, but overall, because of how easy it is to use, it is the most commonly used rigging mechanism, or rigging in FTC. Next up, we have cascade rigging, which uses multiple individual strings for extension and retraction. Here you can see that there is one red string that goes over stage 0 and onto stage 1, and one that goes over stage 1 and onto stage 2. And for this one, all the slides extend and retract all at once. The advantages for this one is that it's extremely fast. Because, for example, if you pull in a certain amount of string here, it's going to pull this up a certain amount. It's going to pull stage 1 up an amount. And the string for stage that goes over stage 1 is going to be pulled here. It's going to be pulled on the side that connects to the base, meaning that the stage 2 is pulled up, and that sort of like cascades all the way to the top, which means that you'll go up however many times faster as you have stages. Unfortunately, because you have so many different strings you have to mess around with, they're often fairly difficult to tension, and extension is not 1-to-1 with spooling. Finally, for retraction, there are a couple ways to retract your slides. First of all, and the simplest is just gravity. Gravity only really works for slides that are going vertically, because otherwise you'll end up with some component of gravity that's going into the slides, and that creates friction. The advantage of this is that you don't have to run a traction string. All you have to do is run an extension string, so it's very simple. Next up, you have continuous retraction, which is rigged similarly to continuous rigging, where you have a single string that goes up and down your slides, except it's on the other pulley this time. It's on the opposite pulley. And just like continuous retraction, it has a 1-to-1 spool to retraction ratio. You also have cascade retraction, which also has a similar rigging to cascade extension. And once again, the retraction ratio is 1 to however many slides you used. And finally, you have tubing, which uses elastic tubing to pull back the slides. And this is also very simple. You don't have to deal with the second string or other more strings they have to tension. But because the force that the tubing exerts becomes less the more the more retracted the slides get, it might need some help on shorter slides, or you might have to over tension your tubing. All right. Thank you all for watching. And we also have a couple other videos on this on our channel about other subsystems if you guys want to take a look. All right.